Hello, this is the MLC Calc 1 Exam 2 for a review for Exam 2. This is taken from the Exam 2 of Fall 2022, which was last semester. We just like to start this review by saying that although our reviews are hopefully an excellent resource for all of you, they are not the only resource and are not entirely sufficient for the exam. Make sure you make a note card. Please read your own notes. Feel free to consult the textbook and work extra problems outside of the gold exams. This is just a good sample size or a good sample to show what kind of questions are asked on exams and so that you can see them worked out in their entirety. That being said, I'll start. There's a blank page, and so this first part will be purely over this question. So we're supposed to answer the following multiple choice questions by circling our answer. No justification or explanation is required. The graph of the function y equals f of x is displayed below. For which values of c is the following true? Select all that apply. The derivative at c is less than the second derivative at c. This means that, well, let's look at the graph, right? So let's just go through these options. At c equals 0, the graph is increasing, and it's an inflection point. Because this is concave, to the left of 0 is concave up, to the right of 0 is concave down, just from observation. Because of this, that means that the second derivative has to be 0. Moreover, the first derivative is positive if we were to draw a tangent line there. Therefore, the first derivative is larger than the second derivative, we can cross out a. So it's not a. At c equals 1, the first derivative is 0 because it's a maximum value. We can see that quite clearly. But the second derivative is negative because it's concave down. So it's not b either. It's not 1. At 2, the second derivative is 0 because it's an inflection point. But the first derivative is negative. And because negative numbers are less than 0, c works. For c equals 3, it's 0, but concavity is positive because it's concave up. So 0 is less than the positive number. For c equals 4, we throw it out for the same reason we did 0. So the answers are c and d, as I just explained. For part 2, suppose that f is continuous and differentiable on the interval from 3 to 10. Also suppose that f of 3 equals 4, and df dx equals f prime is greater than or equal to 2 for all x in the interval from 3 to 10. What is the smallest possible value for f of 10? Here, the idea is to minimize a function value starting at a point. We want to minimize its rate of change. We want to minimize its derivative. If the derivative is larger, it's going to change more by the time we get to f of 10. So we want to assume, so we want to take f prime of x equal to 2. Notice that if f prime is a constant, then f has to be linear. And so we have that f of 3, f of 10 minus f of 3 over, so because it's linear, the instantaneous rate of change is the average rate of change for all points. So f of 10 minus f of 3 over 10 minus 3 is equal to 2. So this implies that f of 10 minus f of 3 is equal to 14. Wrong button. There we go. Nope. Okay. But we know what f of 3 is. It's 4. So f of 10 equals 18. Now, if f prime is bounded below by 2, it can't be negative, right? That simplifies the question a lot. So, which means that any function, any other function which is not linear, is going to have a larger value for f of 10 than this one we took here. So our answer is 18. And it makes, like on a test, you might think, oh, well, that's the largest possible value here. So how could that be the smallest possible value for f of 10? And in that case, you just have to trust your work and your reasoning. So I accidentally imported these a little bit silly. So we only have one question for this review video. But you can catch our other review videos for the rest of this question and the rest of the questions on this practice exam. So happy studying and good luck on your exam.